Hey everyone, welcome back to another episode of Behind the Tech. I'm your host, Ramon Roche. I'm DroneCAN Foundation's program manager, and I'm joined today by an awesome guest, Alex Klimaj. He is the founder of Ark Electronics. He's a longtime PX4 contributor and a really good friend. I am really excited to talk to him today and bring you his story. So without further ado, what better person to talk about it than Alex himself? Hi, Alex.
Hi, Ramon. Nice to be here.
Hey, well, thank you for your time. Thank you so much. This is our second episode. I'm really excited to have you on the very first episodes. I think that we met each other, what is it, like almost like 6 years ago or 5 years ago? Was it like in Interdrone?
Yeah, at Interdrone is where we met in person for the first time.
Yeah. I remember you were working at, what was it? What's the company name? I forgot. Is it
Teal Drones? Yeah.
Teal Drones. There we go. And the whole team joined, right? You actually drove there.
Yep. Yeah, down from Salt Lake to Las Vegas, about a 7-hour drive.
That must have been a nice road trip.
Mm-hmm. Yeah, I'm looking forward to the PX4 Dev Conference in Austin this year.
Yeah, that's going to be amazing. The Dev Summit in Austin, Texas, June 23rd and 24th. I'm going to actually put the link in here so that everyone that's watching can actually go and purchase tickets and see all the details. It's going to be amazing. I hope that you are going to apply to give a talk at the summit, Alex. I'm going to have you on video now, so better say yes.
I'm planning on it. I just need to come up with the talk.
Yeah, time, right? Time. We need more time. Yeah, well, now that things are starting to settle with the pandemic and everything, and that we're sort of going back to, I can't even say normal, and I refuse to say new normal. I think it's a great thing that we're going out of our houses and meeting each other, because that's something that we're kind of missing in the community, like going back and seeing each other and meeting, because that's how everyone got started. And I feel like that 2-year gap actually put a huge pause on that. But there was a lot going on in those 2 years where we kind of couldn't see each other. I think that a lot of people, you included, spent that time creating a lot of things. And we're going to talk about all the things that Ark has been doing in a little bit. But before we actually jump into the topic for today, I think that it would be great if you could give a quick intro to everyone that's watching. The story behind Alex, who Alex is, and what better person to do that than Alex himself, right? I think I already said that twice. So Alex, can you give a quick intro to yourself?
Yeah, so like you said, my name's Alex Klimaj. I'm the founder of Ark Electronics. Currently, I'm working in and around PX4, making CAN nodes and sensors for Pixhawk hardware and with PX4 firmware. My background is in electronics. I'm an electrical engineer. I've worked kind of around electronics ever since high school. I got my degree in electrical engineering. I worked for Agilent and Keysight in kind of spectrum analyzers and oscilloscopes. So I kind of have a background there. That was in technical marketing. And after that, I moved back to Salt Lake City and worked for Code, a barcode reader company, doing design. I wanted to move into design and make sure I kept my technical chops strong. And after working for Code, I got the job at Teal, and that's when I got into drones. And that was the first time I've ever worked with drones. And I went in pretty strong, learned how to do FPV, manually flying, got comfortable with that. And that's where I started working with PX4 and getting to know the community. And then after that, I decided to go out on my own and start Ark Electronics, mainly doing consulting for quite a while. Before I saw some needs in the Pixhawk PX4 community for sensors and CAN nodes, moving things more distributed and fault tolerant, and for longer runs of buses where I2C and SPI and UART weren't sufficient. And now I'm still doing consulting, but kind of a mix of consulting and my own products and supporting those. Yeah.
Awesome. And I think that I sort of saw that transition happening when we first met, and now that you're at Ark, I really appreciate all the contributions that you've made. You certainly did, like, it was clear that you looked at the community and you was like, yeah, I think there's a big gap in there that I can fill. Is that sort of like why you chose to start Ark Electronics, or is that a decision you made prior to like figuring out the gap that you're trying to fill right now?
Yeah, mainly a gap, and there's not a lot of hardware engineers, electrical engineers, doing consulting, contracting around the open source drone community. There seemed like there was a large gap there. A lot of people doing firmware and software, but not a lot of people supporting hardware, and that's where I came in. And so I would say I do mostly hardware, some firmware, and a tiny bit of software. And most of the software I do revolves around MAVLink and MAVSDK.
All right. And I want to bring us back a little bit to a few things that you were said in your intro. So you mentioned that you first got involved in drones when you took the job at Teal. How was it just like coming from your background into like moving into drones, which is like such a like interdisciplinary topic? And how was it for you as a developer getting started with drones? Was there any culture shocks, or was there anything in specific that caught your attention when moving to working with drones? Was there anything interesting about the drone industry that caught your attention?
Yeah, it was mainly, I called it the kitchen sink of technology and hardware, where barcode readers were, you kind of have the same thing every time. You have a camera and a processor, and that's about it. And that's all you do. And you talk over USB, and that's you do that over and over again, and you cost reduce, and really high volumes. So there's certain engineering challenges there, but with drones you end up with the kitchen sink where you've got batteries, you've got cameras, you've got processors, you've got motor control, sensors. It's everything.
What do you mean drones are not easy, Alex? What are you talking about?
Yeah, and they're not easy, but Pixhawk and PX4 certainly make it a lot easier for someone to come in and just get started like me. When I came in, I made hardware, and PX4 wasn't as far along as it is now as far as supporting different hardware configurations. And I think I made the mistake of putting a different sensor on a spy bus that wasn't already supported. And that's where I kind of was into the fire, getting that working in PX4, and the PX4 community, specifically Daniel Agar, helped me quite a lot there, and was holding my hand for a long time. And
oh my God, Daniel is everywhere.
Yeah, you'll have to get him on here. Calling him out.
Let's see if he agreed to do it.
Yeah.
And was that your actual first experience with PX4?
Yep.
Nice, trial by fire indeed. So what caught your attention about working with PX4? Was there anything specific that you thought was helpful and did actually make your work easier, or was it actually a painful experience?
At first, it was painful because I'd never worked with drones before, and I'd done some firmware, but not a ton of firmware. And PX4 is a very large project. So getting into that and learning all that from kind of all at once was pretty difficult. It's definitely gotten easier over the years, and PX4 has come a long way with its configuration and supporting different hardware and making it more modular and easy to make new hardware and switch things up if you want to do custom work, custom hardware, firmware.
Yeah, I agree to completely. Like I think that the biggest thing for me when getting started with PS4 was all the different concepts that you had to deal with, because coming from a non-traditional embedded background myself, it was one of the biggest challenges. And I think, yes, I agree. It is getting better, but it also it's getting better for you because you're starting to learn a lot of those intricacies that are involved within the drone industry and drone development in general. But I think that's just like true for any drone operation and any drone software, I guess, out there, not just PX4, right? It's just so many complex things and topics that are involved with working with drones, like you were discussing at the beginning.
Yeah, so you deal with the same problems every time you make a new drone. The sensors have gotten better over the years, and I was starting to move everything over to the Bosch IMUs. And with the chip shortage, those have been completely unavailable. So that was quite a painful experience, moving all my designs from the Bosch sensors back over to the InventSense sensors, which I have been able to get.
Yeah, no, and I really want to jump into that topic with you later on in the conversation. That's supply chain woes that's been happening. It's been overextending already. But I want to go back a little bit, if you may, about your experience with PX4 when working at Teal. So the question is, do you actually have any problems working with PX4 other than your trial by fire?
Yeah, when I joined, shortly after I joined, the one firmware engineer left, and it became me as the hardware and the firmware engineer, working with the autopilot hardware and the firmware. So I had to really get in and learn and get in there. And it was a great experience because I ended up learning a lot about it. And eventually we brought on another firmware engineer that really helped out there.
Right.
It worked great.
Okay. It worked great. Well, I'm glad,
yeah,
I'm glad to hear that.
There were its quirks, but in the end, we got that so that, every single drone every time would just take off and fly. And, you had to tweak it, you had to tune it, but it, out of the box, it flew, but you had to tune it and you had to work on it and make sure that, you build a whole big production run of them and that every single one is going to fly the same every time.
Yeah, definitely. And do you think that your transition from having two people work on this to being your sole maintainer of that product and being in charge of the PX4 implementation, do you think that it would have been the same learning curve, or would have been harder if the software, the autopilot that was running your drones was actually a private software or closed source software?
I think it would have been much harder since there wouldn't have been anyone there who knew it. And using an open source autopilot firmware, you can leverage the community and the learnings there, the forum, the Slack, and you can learn everything you need there and ask people questions. There's in my mind, there's no reason not to use an open source autopilot, whether it be PX4 or another, when you're starting your product, because it just gives you that leg up. Most drone applications, the product isn't the drone, the drone is being used as a tool.
Nice. I'm going to pull that quote and put it out there. I want to print it. A really nice way of putting it. And once you got another engineer brought on, was it onboarding them on PX4? Was that easy? Was that the same experience as you had, where you didn't have any help?
Yeah, they already knew PX4, so it actually was a big help, and they'd done their own autopilot in the past, so it was a huge help.
All right. So would you say that aside from all the features and everything that PX4 brings into drone, another benefit is actually the community and all the online resources and the content that's already generated, and being able to have a pool of engineers that already know the software?
Oh yeah, most definitely.
Yeah, I mean, that's, I think, one of the things that we don't say enough, and that it's not very, it's not upfront as a benefit when you start looking into an open source framework or tool for any type of job. It's something that oftentimes goes unsaid. It's not just the benefit of the actual software, it's the community behind it and the ecosystem that gets created, right? And that's one of the benefits that the PX4 has. Enough about we'll keep talking about it in the next questions, but I want to continue talking about the present day Alex and what you're currently involved with and how did Ark got created, right? I think that you already sort of discussed that you moved on from Teal and you created Ark, and then you later on found this need in the community that you wanted to address. And I want to talk about more about Ark. So what is it that Ark currently does, and what is it that you actually do? So aside from creating great products.
Well, thanks for that. Yeah, mainly I do consulting and contracting in and around drones and PX4. I have some random other projects that don't involve drones, but mainly in drones. And I've been kind of focusing my work on PX4 and revolving or anything involving drones and PX4. Otherwise, I do my products and do development there, and I have my standard products I offer, and then I also help people customize them for their needs.
So it's like sort of like services and also products.
Yep.
And what type of product do you have? What's your product lineup look like?
My main products right now are CAN nodes. So using UAVCAN / DroneCAN now, they communicate with the autopilot over the CAN bus. So you can put a bunch of nodes on one bus. They arbitrate. They can do collision arbitration and all talk on the same bus. And yeah, it allows you to add more sensors to your autopilot without needing to run. A lot of people run out of I2C buses or UARTs or SPY buses, and then they are kind of stuck. Like the Pixhawk 4 Mini, for example, only has the one GPS port, and then you have some UARTs, and people have those all used up, but you still have a CAN port, so you could add on another GPS or an optical flow sensor. So like this is my standard GPS product. It's got an IMU, GPS, barometer, magnetometer, buzzer, safety switch, kind of has all the standard GPS offerings. Then we've got I call it the Ark Flow, and that is it's got an IMU, an optical flow sensor, and a distance sensor from Broadcom. And this Broadcom distance sensor is really great. It's just hard to integrate by itself. So having it on a CAN node makes that really easy for people to add to their system. And then I've got an Rtk GPS. Everything has all the same as the other GPS, but it has an Rtk GPS module instead of a standard GPS module.
Nice. And why did you? Well, I think you already talked about why, but the question I was going to make is like, why did you choose CAN? But that's not a good question. I think rather the actual question that I think we should be asking is, what role do you think CAN is actually having in drones right now? And how do you see a modern hardware architecture in a drone? Because like you're saying, yeah, there's a lot of flight controllers out there, but one of the benefits of CAN is when you're limited in the ports the flight controller has. But do you sort of see that trend going towards CAN, or is that like a choice that you make, or do you think in the future is not going to be even a choice? So it's like you have to use CAN.
Yeah, when I started working with PX4, there weren't a lot of CAN options out there, and a lot of people I worked with were all saying, "Well, what if we use CAN bus for everything? What if we use CAN bus?" And I thought it was a great idea, but it was a chicken and the egg problem where everybody was saying we should use it, but there were no sensors out there that really supported it, and the ecosystem wasn't quite there. And so a few years ago, when I was thinking back to this and talking to PX4 developers, and it came up again, and went, well, what if we start moving everything over to CAN? UAVCAN exists, and there's just not a lot out there for it yet. And I jumped on and said, yeah, that's a great idea. I actually was the marketing kind of product manager at Keysight for the CAN bus analyzer on oscilloscopes when I was there. So I had a lot of background with CAN bus at the time, and CAN FD. I went to the plug fests and met the creators of CAN, and that was quite a great experience. So I was already sold on CAN bus from the get-go. It was just a matter of making it all happen. And PX4 actually had all the plumbing for CAN, and the firmware was there. There was just not a lot of hardware. So I jumped in and started making hardware, and made all the board configs. My products run straight PX4 right out of GitHub. You can just go download it, customize it, flash it. You can do the boot loading, and the firmware updating is all over CAN too. So that's a big benefit. There's just there's a lot of benefits and not a lot of downsides. It adds a little bit of cost for every sensor because you need a microcontroller and a CAN transceiver to talk over CAN. And that would be the one downside, I would say.
I think you mentioned you were using UAVCAN, DroneCAN.
Yeah. Mm-hmm.
And so when you started working with this, I think the project was UAVCAN 09, right? And then it sort of transitioned to DroneCAN, to what is known right now. And by the way, I want to give a huge shout out to the UAVCAN team, to Pablo and his team, and I think they're doing an amazing job enabling the community. That's another open source project tangentially related to PX4 and to hardware. So you were already working with CAN in your previous work experience. So you were already sold on this idea of using CAN, and you saw the opportunity of bringing CAN everywhere in the drone world. And back then, there weren't a lot of options for using CAN. There's not a lot of sensors. So that was the gap that you saw, that you were like, yeah, I think I should be showing this space, right? And from there on, you mentioned that your products are running PX4. So isn't PX4 like an autopilot for drones? How are they powering a sensor?
So a CAN node and a flight controller will be running the same drivers to talk to each other. There's not going to be a difference there. So that's kind of a short-term now thing. But yeah, you utilize all the same drivers as the flight controller. Those drivers are already written, tested, hardened by the community. And so, instead of reinventing the wheel, you just make a new board config for your CAN node for your product with the processor. The one thing is you need a processor with a large enough flash to fit PX4, since it's decently large, so at least 0.5 megabyte of flash on there. And so you do the board config, you build it, and then you have a bootloader that's it's also in PX4 itself. So you build the bootloader, you need to flash that over, like SWD, the debug port with like a J-Link or an SD-Link. And then from there, you can just load firmware from the flight controller to the CAN node.
Through CAN.
Yeah. You build the binary out of the main PX4 tree, and then you put that on the root of the flight controller SD card, and you hook it up over CAN. It identifies it using the bootloader, and then you can update the firmware, and you don't have to touch that debugger again.
Nice. And when you say it's just running PX4, is it like a full-blown PX4, or is it only taking advantage of a few things? So you mentioned sensors, and you mentioned, I think before you mentioned that PX4 already had all the pipeline for working with UAVCAN. So is it true that it's turning off a few modules to be able to fit into the space required for the sensors that you're building?
Yeah, right now, if you're using, like most of my products use a 0.5 megabyte of flash minimum. I kind of mix and match in other larger flash sizes, but it's still limited to the 0.5 megabyte flash. So to fit on that, yes, you have to turn off a lot of the modules in PX4. So I wouldn't say it's not full blown PX4 that fits on like a 2 megabyte flash STM32 F7 or H7. So for 0.5 meg, you have to turn off quite a bit. The long-term goal is to get all of the basics to run the EKF down to fit in 0.5 meg or 1 meg flash, so that all the CAN nodes can run the EKF itself, and you can kind of have this distributed architecture of the flight controller. So instead of sending raw sensor data back to the flight controller, you'd run the EKF on every single CAN node. Part of the reason I put an IMU on every node is so that you can run the EKF on there, get an estimate, and then send that back over CAN. So that's the long-term future goal. I'm working on a generic CAN node that'll have PWM outputs. So kind of the pie in the sky idea is you don't even have a main flight controller with a big processor. You have a bunch of CAN nodes all running their own EKF, and then one CAN node with the PWM outputs. So you could kind of have this distributed flight controller throughout your vehicle. That'd be the long-term vision of where CAN nodes are going.
So you took what was already there and you put in the PX4 Can Node and the current state, and then you're already thinking ahead of time, ahead of like the curve, and seeing like, okay, we think it's good idea if we run distributed parts of PX4 around the architecture of the drone and feed that data back to the flight controller instead of sending the raw sensor data. And that is amazing.
I think the long-term vision with UAVCAN and DroneCAN, DroneCAN, will define a certain set of standard messages that for raw sensors. And then you could have a UAVCAN V1 coexisting on the same bus and do like a pub sub bridge from UORB over the flight controller so that you can just subscribe and publish. And if there's both ends could figure out what's supported, and you could use one or the other or both. So I see a long-term goal of DroneCAN and UAVCAN being both supported and living together on the same CAN bus.
Okay, so this sort of answered my question, the questions that I had prior, what I asked you about. Do you think CAN is going to be like the future of architecture in drones? And I guess the answer looks like a total yes. So why wouldn't you want to have the benefit of being able to run distributed modules within your system? And it's amazing that you've been working with Daniel and PX4 devs to enable this. And so you already prepare for this future, right? So it's not currently implemented that you have distributed, let's say EKF, but it is, your hardware is already ready for this. And is that true for the Flow, the GPS, and the Rtk?
Yep, they're all ready to go. They just need the firmware there, kind of a full inertial navigation solution.
That's amazing. Yeah. Thank you for working on that. And what else is in your plans for Ark Electronics? Are you thinking of, or maybe even working on current new products out there that you can actually speak about in the podcast?
Yeah, I mentioned the generic CAN node with PWM outputs. Mm-hmm. So that will be for the more advanced user, the developer who wants to, they have a sensor, let's say, that's not on one of my nodes or a node that's out there, but they want to put it onto CAN because they've got a large vehicle and they want to put a sensor far out somewhere. So that, has I2C, SPI, UART, and PWM connectors, Pixhawk standard connectors. So they could connect it up there. We're going to try to support a number of default sensors in the main build, but if it's not supported there, you can either build it in if it exists or write your own driver and put your sensor on the CAN bus with this generic node. So that's in the near term. Long term, I'd like to come out with a FMU V6X US made flight controller in the Pixhawk Autopilot bus form factor, which Holybro has the V5X right now. And yep. That's based on the Pixhawk Autopilot bus standards. And that's getting everything moving. And I know the Skynode uses that same form factor for its flight controller. So there's already a few options out there in the market. And it would be really nice to have another flight controller that I'd be able to offer as a drop-in replacement. Yeah,
when talking about the Pixhawk Open Standards, and especially the FMUV5X and FMUV6X Open Standards, there's quite a few companies that are already working and manufacturing them. And there's a lot of questions that I get sometimes by the community. Is like, why is there X company building this if a Y company already has like this implemented? Like, let's say Holybro's 5X. Why would like Ark try to build another 5X or a 6X? And instead of me answering the question, you kind of sort of mentioned the US made reasoning behind building one, but is there any other type of reasoning why you think there is the community benefits from diversity in building an open standard for a flight controller?
Yeah, having more options is always better. That's my main thing, and having more companies to buy from, especially if they're drop-in replacement, make sure someone building a drone or any rover, any vehicle with this, have more options. Let's say they're out of stock or you can't buy them, or a company goes under, you have other options to make your product more resilient for supply chain problems, having more options to buy there. And plus, being based on an open standard, like, you can always go build your own and drop it in, and it's not a proprietary connector or pinout or anything like that. So the open standards are definitely the big benefit there, and I think just more options are better.
Yeah, and I think one thing that sometimes the community doesn't understand is that the open standards only define the pinout, and they actually don't define the mechanical design of it or any of the different ports or different mechanics that you can have. And actually, some of them don't even define the sensor set. So any manufacturer can work to change that sensor set as long as those drivers are already supported within PX4, right?
Yeah, and it's a big benefit. I have a number of clients I've built drones for with, going chip down and just customize, use the STM32H7 and put in different sensors, especially with the chip shortage, finding what's available, putting those on there, and then they can actually build hardware.
Yeah, the supply chain crisis has been really bad for everyone. I hope that you have been stockpiling those H7s.
Yeah, I have my little stockpile of parts.
I feel like everyone has their stash.
Back orders come in. You have your back orders placed, and they say 52 weeks, but they slowly come in over time.
Yeah, definitely. And then by the time you actually get around to building that, you might already have enough stockpile to offer a good product. And I really would like to see what you come up with the B6X design. Speaking of everything you've done already, with great hardware, with good quality. And this is not only me telling you this, because I actually haven't had the chance to play with your hardware personally, but I've heard that from a lot of other members of the community where everyone's really happy with your hardware. So, and I would like to talk a bit, if you can, about what sort of clients that you work with in Ark and what sort of their needs are. And I'm guessing there's mostly revolving around sensors and CAN, but maybe you can share more about that.
Yeah, actually, I don't think many of my clients are using CAN right now because they have a really specific use case that, let's say one of my clients is Acre. They're a crop diagnostics company. They started with flyovers using fixed wing drones for doing, flying over crops and getting data there. They created a hand probe that you carry around, and you take pictures and you do machine learning with environmental readings in a crop. And so they came to me and some other of my colleagues and wanted to take that and put it on a drone instead of walking through a field of corn getting cut up by the blades on the corn. The whole goal was to beat the time to fly the same size field with a drone. And we came in and, used PX4 for the autopilot for the flight controller, got that all set up and flying. That's all stock. And then on the probe end, running MAVSDK and communicating over Wi-Fi for telemetry to the drone. The whole thing runs on there, and it's a fully automated MAVSDK piece of software that the probe hangs from the drone and commands the drone. It's pretty funny to see this probe hanging off a drone, 10, 20 meters down, swinging from the drone, controlling it, and it tells it where to go. And then, you drop it into the crop, and it has an IMU that senses when it touches the ground, and a little touch probe too, the tension probe to see when it's not under tension. And then it tells the drone to bring it up, and it takes pictures and video of the crop, and then tells it where to go to the next place. And then all the proprietary stuff is in their machine learning, their diagnostics, everything. The drone, like I said, is a tool, and leveraging open source just, made that possible.
Yeah, I think that's the reality of the drone industry. Like drones are just tools, right? They're just there for capturing sensor data.
Yeah, you need to put something in the air or on the ground. It needs to be autonomous, semi-autonomous, and using open source gets you there. You wouldn't recreate a networking stack when TCP/IP exists.
Yeah, definitely. And that whole use case that from your client is actually really interesting to hear about. I actually had no idea they were doing that.
Yeah,
I'm guessing
got thousands of hours over the last few years, last few growing seasons on that system, and it's just PX4
the MAVSDK
in the background doing its job.
Nice. So I think that Julian and Jonas from the MAVSDK team are going to have a good time hearing this.
Yeah, MAVSDK is great when you have one companion computer controlling one drone. It starts getting a little hairy when you want to control more. I've got another client doing drone light shows, and that's all leveraging PX4 and MAVSDK, and all the proprietary stuff there is in their show creation and development and path planning. And once again, the drone is just there to do a job, be in a location that they tell it to. The hard part is in creating the shows.
Oh yeah, most definitely. And they're also using MAVSDK, right? So
that one actually isn't using MAVSDK. MAVSDK, okay, like I said, doesn't scale very well for multiple drones.
Okay, then I misunderstood. I thought you said they were also using
station with hundreds of drones. MAVSDK is a little heavyweight for that. So that's where more of the proprietary stuff comes in.
Do you think that's a MAVSDK fault or more of like a MAVLink networking?
It's a little bit of both, because you also have custom the MAVLink messages themselves are just too large for. Mm-hmm. You can't even have heartbeats with that many drones. It bogs down your network. So you're talking, custom MAVLink binary messages that are really small.
Yeah,
to make sure that everything talks.
And do you think that is there anything that we could do within PX4 to sort of alleviate that in the future?
Yeah, I mean, you would have like even a super minimal. There's minimal MAVLink message set, but even minimal is too large. So you almost have like to define an even smaller, like the Iridium MAVLink message set is close, but you're still talking. It just doesn't scale when you have hundreds of drones.
Yeah. So would you choose some other communication protocol instead of MAVLink, or
no?
Like they're saying
MAVLink works. It's more of a kind of a niche thing. I don't know if you necessarily need to support it in the open sources, where the open source gets you most of the way there, and then you have to bring it over the line with the proprietary stuff.
Most certainly. Like we're only trying to be like this 90% solution where like everyone writes like their custom stuff on top. But I gotta say, there's a lot of companies out there using PX4 for light shows. And I gotta wonder if there's anything we could do to support that use case better. And now that more modern hardware are starting to support actual IP-based networking, I wonder if there's anything we could do to extend the middleware maybe to some degree to help them get access to sensor data through UART maybe. Yeah,
maybe. I mean, with the V5X, you have Ethernet, and that's supported on there. And so you could do higher rate stuff with that. And it just depends on where you're doing the control, whether you're on a companion computer or doing the control within the flight controller itself, and where you split that up. Because I know people use offboard and send commands from companion computers, and I know other people doing it all internally. So it's kind of, there's multiple ways to arrive at the same solution.
Yeah, and that's for the companies that are using PX4. But because I know of other companies doing light shows not using any open source software, they do a different thing where they actually do all the processing on the ground station, and that communicates back to all the swarm of drones and sends the position data. So that's like one more different way of how to architect this. And I think in software and like open source and the way we work, I think at some point we should start writing, or maybe we're already doing this, like knowing Daniel, he's already thinking about this, of a way to like extend our utilities or tools to benefit that sort of use case where there's a need for more data with the higher bandwidth and I would say in higher frequency, right?
Yeah, at a certain point, it just comes down to communications theory, how much data you can pack over in a bandwidth on a frequency. Yeah,
and what other use cases do your clients have in here? And I am interested in learning about this because it's good. I think that it's great for reviewers to learn all of the cool use cases and all the cool examples of how PX4 or maybe just open source in general is getting implemented at.
Yeah, off the top of my head, I kind of in the near term, what I've been working on, I don't have many more right now.
That you can speak of.
Yeah,
I'm sure.
Yeah, but a lot of my customers, with the CAN nodes, I hear from some of them what they're doing, flying in caves, flying in tanks, in tank inspection with in GPS denied applications for using the optical flow. I hear about that. I hear from such a small percentage of people who purchase my products that I don't actually know necessarily what they're all being used for, because you can customize them and use them in your own use case and write your own firmware and do what you need to do there. I know there's one client out there, customer using them they have their own EKF, custom EKF in PX4 that can control off of vertical surfaces. So they've switched and do control with a optical flow sensor off of a vertical surface, which is really interesting. I know PX4 has plans long-term to support arbitrary flow and distance sensor orientations. So hopefully in the future, that is something you can just enable. And instead of all assuming that the optical flow and distance sensor are downward facing, you could say this is, forward facing, side facing, up facing, just an arbitrary angle and orientation on the vehicle for kind of rudimentary collision avoidance. Not quite a full visual, but a single point with some data is kind of interesting.
Yeah, definitely. And I want to point out something. So we were discussing some of your clients before, but those are the ones that you're actually doing more like services, right? And the first two use cases that you showed us. And then you're mentioning that for the ones that actually purchase your CAN products, you don't really hear back from a lot of them, right? Because you sell a lot of units, but not a lot of them actually reach back to you.
Yeah, I hear from some of them up front or later on to support them, and others I never hear from. And later on I hear, yeah, it's working great. Oh, okay. That's all I know. Yeah, but then so I've got my consulting clients where I actually implement solutions from scratch there, and then I've got my product.
Well, I hope you get to meet a lot of them in the Dev Summit in Austin.
Yeah, I'm excited. I'll have to come up with a good talk, and everyone let me know what you want to know. I'm kind of thinking like maybe starting like a CAN node from scratch, hardware, firmware, walk through there, maybe with the new product, the CAN node, generic CAN node, kind of adding sensors and building that for your use case. I don't know. Let me know.
Yeah, let them know in the comments below. That to me, that sounds like a wonderful talk. So you should start writing. You start typing that application in the CFP. Thank you for all the beautiful examples that you've talked to us about from your clients. And I know that there's a lot of sensitive data you can't share. I appreciate a lot of the work that you've been doing, especially because there's not a lot of people that see the opportunity to fill a gap within the community in the market, and you dare to do so. And it actually is starting to pay out a lot, right? So you saw the opportunity, you took it. And to me, it's just a wonderful success story from the community. So you started working in drones and open source. You didn't even have an idea what PX4 was. And then you started contributing, you liked it, you helped others to come on board to start working with PX4. And then you went outside that company, started another company, and then specifically to work with drones and to serve the needs of that community. And that you further saw that and started solving specific needs by creating products. And one thing that we haven't actually discussed is your involvement with Drone Code Foundation and the work groups, because we talked about FMUV5X and some of the open standards, but we didn't actually mention that you helped create those standards to some degree. You were involved in the meetings and in the work group processes. I think there's quite a few other work groups that actually concluded, but we haven't actually published the open standards like the BMS one. And I know that you have a BMS, say, hiding around your desk somewhere. Can you talk to us a little bit about your experience working with the Drone Code Foundation and the work groups and the other companies involved in the Pixhawk work groups?
Yeah, so like you said, I was involved pretty heavily in the BMS work group, and this drone flies my smart battery prototypes exclusively, and we defined a pinout, we defined an interface, which we landed on CAN bus, because you can support multiple batteries easily there. I wanted to bring that product to market, and it's really hard to bring a battery to market. So that I kind of put on the back burner for these other products. I am working with a partner client company to bring a 12S smart battery to market. That has the AS150U connector and will have CAN bus, be running PX4, and that should be on the market later this year. And so that is leveraging the Drone Code BMS smart battery standard and that message set. So we worked on defining, as part of that, we defined a smart battery MAVLink message in MAVLink 2. And so that was a community effort to get more smart battery info over MAVLink. It's just trying to decide on a standard battery is really tough with all the different needs of vehicles.
Yeah, and then defining a standard in particular it's always challenging, because there's different companies with different needs and they have different ideas of how to implement things. And when we were working on the BMS standard, I think there were somewhere around like 8 to 10 companies involved. Of course, not everyone participates all the time and gives feedback, but when there's time to define the actual pinout, like some of them care for different things. And I remember we even had discussions about what sort of units to use and if we should define in the message, and if there should be any conversion done before sending the message, and if that should have been handled by the BMS systems. And I know that there's a few discussions yet to be had on the BMS work group to actually publish the standard, and I want to have those. I think we should use this podcast as sort of way to pick up that effort and ping those companies and like say, hey, let's just get this out of the way and publish the standard, because it is definitely a benefit for the whole community. And you sort of did a lot of the work for that. So let's just try to do that again and get it out for the greater benefit of everyone. But I think if you actually search around online, the people that are viewing the video can find I'll leave a link to the draft BMS standard under the video description. And there's other work groups. Well, it's the same work group, but there's other standards you also help create. Were you involved in the FMUV5X or 6X design process?
A really small amount there. I was listening in and involved and spoke on them a little bit, but not as much as the smart battery. And then there's the radio, Pixhawk radio interface.
Oh, nice. I didn't know you were involved in that. I actually was involved in another thing that was happening during the same time, and I was coming in and out of that work group, and I didn't pay that much attention as I should have. But I want to say that as of the one we're recording this video, the Pixhawk radio interface standard is already published and is available. We haven't actually announced it yet as of the date of the recording of this video. So maybe when we publish this video, it's already been announced. But that's an actually really cool standard that got created. And can you tell us a little bit about what is that this standard is and what the sort of goals behind were? Because when it was first brought out to my attention, I actually didn't fully understand what it was for, because there's a lot of telemetries out there and they've already used a lot of like the same ports and same interfaces. And this seemed like a little bit overkill to me in the beginning. But once I started actually understanding what it was, it actually really made sense.
Yeah, it's more of a standard for the ground control station for like a handheld tablet to define a pinout and some interfaces and kind of a mechanical solution for this radio interface, so that a manufacturer can design a ground station that has this standard interface and then can swap out radios on the ground easily. So it's less so for the air side and more so for the ground side. And there's all these different IP radios that have Ethernet, USB, UART, and this defines the interfaces to be able to handle all of those. So
this is a connector, it defines a pinout, right? So then the connector. So let's say you have a tablet that has a controller plugged in. So right now, most of those solutions already have the telemetry built in. So this would help me as a customer, let's say, in exchange telemetries between the ground station tablet.
Yeah, more so for the IP radio for video, video and telemetry, but higher bandwidth interfaces that could handle video, and you could swap them out in the future and have a little bit more future proofing of your ground station instead of having to buy a new ground station every time you want to swap your radio interface to your vehicle. Yes. Or even have multiple vehicles with different radio interfaces and be able to just hot swap them, from one flight to the next.
Yeah, sorry for interrupting you. I was actually going to ask about that. So if I have a good ground station that I know and I like, and I have different vehicles, but they're using different radio systems. So this means that I might be able, if it's these radio systems are compatible with the Pixel Radio Link standard, I would be able to plug and play the receiver within the ground station and just take the same tablet to another vehicle and use that, right?
Yeah, correct.
That's amazing. That's amazing indeed. So there seems to be a lot of open standards going on, and thank you for participating in that. And by the way, I want to give a huge shout out to Tanya from the Rotarian team for leading that specific work group. She did a fantastic job at rallying feedback and pushing the standard through so that we can get that out as soon as possible.
Yeah, she did a lot of work.
A lot of it, yeah. And I look forward for a lot of companies implementing this standard too, as well as the VMS once we actually get it published. I think the benefit of like getting the open standards is almost equal as the benefit that PX4 had initially, in my view, where there needed to be a standard way of how things worked, right? And I think the same benefit that applied to the most drone companies implementing PX4 back then, it will start making sense for companies to start implementing the open standards, where they actually start seeing that a lot of that knowledge transfer happening between X products and Y, and like being able to exchange things and not having to reinvent the wheel, right? Because there's a lot of things that a lot of people are just reinventing. I think one of the greatest examples is like the Payload Interface, where a lot of companies were putting out their own gimbals with their own custom interfaces, and customers that bought like a 5,000 to 10,000 payload now were stuck with this airframe that, and this payload that they couldn't actually take into another frame. And that was crazy. So now the same concept is going to apply to different components within the drones. So, and this is sort of like a nice summary to what we're discussing today. So you had the CAN and your CAN interface and your CAN components and the modular architecture of drones, and now working with open standards, and sort of like the same way where things are becoming more modular, more standardized, and it's to the greater benefit of that community and the drone industry in general, right?
Yeah, it's like I said earlier, it's a chicken and the egg problem. It's if you build it, they might come. you have to put something out there and get the ball rolling to get anywhere. Otherwise, it's kind of a fruit, kind of a thankless job for a while until the ball starts rolling. Like you said, it takes a long time to get people to start adopting open standards and standard interfaces and CAN bus.
Definitely.
Like the radio interface, there's no products on the market right now with that, but it's out there now. And so somebody can get the ball rolling, getting products developed for that.
And that sort of is a reality behind working with open source and open standards, where it's one thing if you write this great piece of code and you put it out there, maybe GitHub, and put it in an open source license. Nobody is going to just come magically and appear and start using it. And you're going to create a community out of nowhere, right? You have to actually invest in making that happen and going and evangelizing for those open standards or that open source. And I want to take that opportunity to mention that is one of the benefits of working with DroneCAN Foundation, where we already have a community of companies, we already have a community of developers. And if you bring in your ideas and your thoughts about your problems to say, hey, we have this problem, which we think, and we actually see other companies having, and we sort of agree that maybe we should solve it together. And that's, by the way, how most of the work groups get created, right? And by choosing to work with us, and by us, I mean Alex, myself, and the rest of the community, you actually will have a better kickstart when you publish the standard, where there's going to be already a group that already knows about it and has had their feedback on it and has helped you push it through. And that's the power and the main benefit of the community, right, Alex? And Billy, and you can correct me if I'm wrong here, and I'm totally mischaracterizing this. But I think that's one of the main benefits of working with DroneCode and working with the open source community.
Yeah, I think it's like the early days of the internet and networking, where you had all these different networks at all these different universities and government agencies doing their own thing, their own protocols, and then slowly over time realizing they needed to standardize on something to start working together. And then as things standardized and people learned those standards, it made everything just go so much faster with the development of people jumping around to different companies, coming in already knowing the technology and building the new product, the new thing on those technologies and open standards. And look at where we are today, talking to each other over the internet.
And I hope that in the next few years, when we look back at this recording, we're going to say, yeah, we made it. And the rest of the community are going to be like, yeah, I mean, it was obvious, the benefit was obvious to everyone. We just picked it up. But like you're saying, the reality is that, yeah, we put things out and we have to do things. We have to work to evangelize and to get people to try things out. That's, by the way, one of the main reasons why we are doing the podcast, so that we can highlight the great companies that are working in the community, but also the efforts that we're putting behind the community to get the work done and to evangelize for all those great standards and open source projects that we're working with.
Yeah. Thanks for putting it together. I love listening to podcasts. I always have a large queue on my phone of podcasts I'm listening to. So I thought it was a great idea.
Well, I'm certainly doing my best effort here. I'm not the expert, but we're trying something new, and hopefully it's working for everyone. And by the way, we're reaching the top of the hour, and we actually passed it a little bit. And I think we're already running out of things to cover on our script that we put together before we started recording. So I want to give you the opportunity to give a shout out to your company, maybe mention website, if you have any social media, any sort of resources that you want to share with the community, and if there's anything else you want to mention before we end our video interview today.
Yeah, great. So my company is Ark Electronics, ARK. Those are my initials. That's where that came from. My website is arkelectron.com, not Ark Electronics, arkelectron.com. I'm on Twitter at Ark Electron, and I post on LinkedIn a lot for my name and my company. So add me there, and feel free to reach out. Let me know what you need.
He's, by the way, totally available for business opportunities. So you make sure to reach him. Hey, Alex. Well, thank you again for your time. I had a lovely time chatting with you. This was a nice interview. Thank you for agreeing to doing this. And I hope that, like you said, you apply to the CFP and the Dev Summit, and I hope to see you in Austin.
Yeah, thanks, Ramon. I'm excited to see you there and everyone else.
All right. Well, thanks, everyone. I'm going to say bye to Alex now. Bye, Alex.
Bye, Ramon.
Everyone, well, thank you again for your time. This was an amazing video podcast interview. I hope that you enjoy yourself as well. Please remember to subscribe to the PX4 YouTube channel, like the video, and visit all of the website and social media, all the resources that Ark Electronics has for you. And I guess I'm going to see you in the next episode. Thank you again for your time. Talk to you soon. Goodbye.
Yeah, so behind me, I've got Abby. She's a rescue cavalier we adopted almost a year ago. She's our third rescue cavalier. And then I've got Gaston. He's a rescue husky German Shepherd mix. And then
oh my God,
behind the chair is Gracie. Gracie, come here.
Oh my God, they're all coming here.
There they are. There's Gracie. She's a Springer.
So lovely. We started recording and there was like, yeah, I want to get in the video. I want to be on the podcast.
Yeah, they have to hang out here with me.